All right, so in this video, we're going to solve a system of linear equations by graphing, okay? In this first example, we've already got two equations that are in slope-intercept form. So graphing these should be pretty quick and easy, all right? So with the first equation, we've got a slope of 3 and a y-intercept of -2, okay? So when we graph that line here, okay, you're going to see it's going to look like this, okay? You've got y-intercept of -2 and then a slope of 3, up 3 and over 1 repeatedly, okay? Our second equation, y equals 2x plus 2, we've got a slope of 2 and a y-intercept of 2. So when I graph that over here, okay, I've got a y-intercept of 2 and a slope of 2, so up 2 and over 1 repeatedly, okay? Now when we're solving by graphing, what we want to find is the intersection point. That's going to be the solution, okay? So I need to move my graph down here so I can get to that intersection point. So on Desmos, which is great for solving systems by graphing, you just want to see where these two lines intersect, okay? We're going to touch that point right there, okay? And you're going to see the solution, okay? The solution's 4, 10, because that's the intersection point, okay? So our solution, the lines intersect at 4, 10, so that ordered pair is the solution to this system, okay? If you plug in 4 for x in either equation, you're going to get 10 for y. So 3 times 4 is 12, 12 minus 2 is 10, that's the y coordinate. And the second equation, 2 times 4 is 8, 8 plus 2 is 10, and again 10 is that y coordinate. So that's why this is the solution. It works in both equations, and it's the intersection of the two graphs, okay? All right, with number 2 here, okay, we've got a couple of equations. These are in standard form, all right? So the quick way to graph these is by finding the intercepts, okay? So with the first equation, remember to find the x-intercept, we're gonna plug in 0 for y. So this goes away. So 2x equals 16, so my x-intercept is 8. To find the y-intercept, we plug in 0 for x. That goes away, so I'm left with 4y equals 16. So the y-intercept is 4, okay? So when we graph that one over here, again, notice you've got your y-intercept at 4 and your x-intercept over here at +8, okay? With my second equation, all right, when I find the intercepts, again, plug in 0 for y, I'm left with x equals 2. Plug in 0 for x here, and I get my y-intercept to be -1 over 2, -0.5, okay? So when I graph that one here, I gotta plug that in here, x minus 4y equals 2, okay? So again, you see the y-intercept here at -1/2, you see the x-intercept at 2, okay? So again, remember, we're looking for the intersection point, and it looks like it's gonna be here at 6, 1, but let's touch it anyway. And again, 6, 1 is going to be my intersection point, so that is the solution, okay? So because the lines intersect at 6, 1, that ordered pair is the solution. Again, if you plug in 6 for x and 1 for y, you should get a true statement in both equations. Just real quick, let's check it in the first one. 2 times 6 is 12, 4 times 1 is 4, 12 plus 4 is 16, okay? So that verifies that that is the solution of this system. All right, so in number 3 and number 4, we've got a special type of system here in each of these that's not going to have a typical solution, okay? So let's look and see what happens in both number 3 and 4 here. All right, so again, we've got two linear equations here, both in standard form. So we're going to find the intercepts, okay? So the x-intercept, when I get rid of the y here, is going to be -5. The y-intercept is going to be -3, okay? So when we graph that, we've got an x-intercept of -5 and a y-intercept of -3, all right? With my second equation here, okay, when the y goes away, my x would have to be -10, and when I get rid of the x here, my y-intercept would have to be -6, all right? So let's graph that over here. So we've got a x-intercept here of -10 and a y-intercept here of -6, all right? Now, if you'll notice, no matter what I do here, you know, moving this graph, you see these lines are never going to intersect because they're parallel, okay? Because they have the same slope, they never intersect, okay? Well, if the solution is the intersection point, and there is no intersection point, then we say this type of system is going to have no solutions, okay? So if the lines are parallel, there are no solutions because there is no intersection, all right? Let's look at 4. 4 is a little bit different. All right, so finally here in number 4, we've got two equations again in standard form. So let's find the intercept. So the first equation, the x-intercept is going to be positive 4, okay? Now the x-intercept is going to be a fraction here, the y-intercept. When I get rid of this, when I plug in 0 for x here, y is going to have to be 8 over 3, okay? So when I graph that over here, 8/3 is right up here at 2 2/3. So that y-intercept is going to be just south of 3. And then my x-intercept here is 4, okay? So see that blue line there, all right? Now with my second equation, negative 4x minus 6y equals negative 16. What I've done here is just kind of multiply everything by a negative 1 to make it all positive, okay? So my x-intercept is going to be 4, and my y-intercept is going to be 8/3 again. Notice they have the same x-intercept and the same y-intercept. That makes them the same line. So you see the blue line here. When I graph my second equation, okay, it's going to be the same line. All right, so notice how that turned green when I clicked on this equation. If I click back up here, the line goes blue again. So those lines are the same, okay? These equations are the same. So what we say is those lines coincide, okay, because they're the same line, blue or green, okay? So they are continuously intersecting, and therefore we say there are infinitely many solutions, okay? Infinitely many solutions for a system where the lines end up being the same, okay? So that's the two special types of solutions you could have. No solutions for number 3, infinitely many solutions for number 4.